implicit function. Implicit function. I think we are left with 3. So we have implicit function. Implicit function. We have implicit function. Sorry. So implicit function simply means a function within another function. Do you get it? So you have a function, but with that function, you also have another functions. I hope you get that. So let's say, and most of the time, the implicit function we use product rule to differentiate them. Most of them has what multiplication of two functions in one function. Do you get it? So you need to separate them or differentiate them using the product rule. Okay, so suppose you have 2xy. You see, you have what? Xy. They are multiplying, right? And so this time around, you need to differentiate them using what? Product rule. Just so you see, you have x and y. So you differentiate them using the product rule. The product rule, we say this u, this v. Hold one constant and differentiate the other. So if you hold y constant, you differentiate x. If you differentiate x, you get 1. Then you say plus. Now you hold x constant, then you differentiate y. When you differentiate y, you get the y dx. Have it in mind. Anytime you differentiate y, you get the y dx. But anytime you differentiate x, you get 1. I've already proved it to you. And also, if you differentiate x, you get the x dx. And this one cancel out to give you 1. You get it. But anytime you differentiate y, you get the y dx. Have it in mind. Okay. So with this simple question, if you are to differentiate 2xy, this implicit function, and sometimes you have some things attached to it, but this is a product rule. So we are trying to do this one before we get into the question so that everything will be simple. So this one, you hold one, the 2 is multiplying the 2 of them, right? So it's either you say 2 into brackets, you hold one constant, that is x, and you differentiate y. If you differentiate y, you get the y dx, plus you hold y constant and you differentiate x, you get 1. So you have 2 into brackets x dy dx plus y. Okay, so the 2 multiply through. So you have 2x dy dx plus 2y. That is it. So this question, when you apply the product rule, this is the final answer. Okay, yes. So let's take a question under the implicit function. Then we move on. So the first question has no product rule. It's just the power rule, simple calculation, addition and sum. Sum and differences. So we have xy plus y squared minus 2x minus 6y plus 5 equals 0. So we have to find dy dx. Okay, dy dx. That is what we are supposed to find. So simple. If you differentiate x, this x squared, you get 2x, right? Plus, if you differentiate y, you get dy dx, right? This y squared. So you get 2y dy dx because it is y. So you bring dy dx minus, if you differentiate this negative 2x, you get negative 2. This negative 6y, you get negative 6 dy dx. I hope you understand. Anytime you see y in the function and you differentiate it, you attach what dy dx to it. But if it is x, you leave it like that. Then this one will give you 0 because it is a constant term. Okay. So now you have dy dx. So you have to group like terms. So you have 2y dy dx minus 6 dy dx equal to, this one will cross the equal sign, so negative 2x. This one will cross the equal sign, plus 2. Okay, so when you come here, you are factorizing what dy dx out. So you have dy dx into bracket 2y minus 6 equal to negative 2x, or this negative 2x plus 2 can be, you can rewrite it as 2 minus 2x, something like this. Okay, so you divide this one by 2y minus 6. 2y minus 6. So this one cancel out this. So dy dx equals, you have 2 minus 2x over 2y minus 6. You can leave your answer here, but because you can factorize the common factors out, for the top you can factorize it and get 2 into brackets 1 minus what, x over, here you can factorize 2 out because 2 is a common member, 2, then you have y minus 3, then this one cancel out this, so you have dy dx as 1 minus x over y minus 3. So that is what we have here. Okay, so that is our answer. That is our answer. So in this case, this is the first differential, and if you are asked to calculate the second differential, you see this is the first differential, so you need to you need to differentiate this one again to get the square y over the x square. And how do you do it? Because it is divided, you need to apply what, the quotient rule, before you can differentiate it to the second differential, the high derivatives. I hope you remember that. Okay, so this is the implicit function. This is the implicit function. Let's take one last question, then we say bye bye to implicit function. So now we are going to solve a question under implicit function. You could see that the other one that we solved, we didn't have a product function, that is 2xy. We didn't have any product function. It was just a single function, x squared plus y squared. But right now we have a product function, and this one too, we have solved it, and you know how to solve the product function. So let's start with our solution. Let's differentiate this to get 2x, right, plus, now this one, the 2 stands outside. So product rule, you hold one constant, you differentiate one. So you hold x constant, you differentiate y to get dy dx, plus, now you hold y constant and you differentiate x. And when you differentiate x, you get 1, right? Okay, now we continue, plus 3y squared. This one will multiply this to give you 6y. Then you reduce here by 1, so it is the same 6y. But because we have differentiated what, y, we have to introduce dy dx. So dy dx equal to, this is a constant term, so 0. This so we expand the brackets by 2x plus, this one multiplies this to give us 2x dy dx plus 2y plus this one, that is 6y dx over dy equal to 0. Okay, so now we have this, we are grouping like terms. We have dy dx, we have dy dx. So let's group like terms. So 2x, we have 2x dy dx, and we have plus 6y dy dx equal to, this one will cross the equal sign, so you have negative 2x, and this one will also cross the equal sign, you have negative 2y. And so you group like terms, you have 2x plus 6y dy dx outside. You see that? Then equal to negative 2x minus 2y. So here we want to make dy dx the subject, so we have to divide both sides by the coefficient of what, dy dx, that is 2x plus 6y, 2x plus 6y. So this one cancel out this. Now we have dy dx equal to negative 2x negative 2y all over 2x plus 6y. This is the answer, but you can see initially the examples that we have been solving, when you get to your final answer and you can factorize the answer, you need to factorize the answer. Do you get it? Because sometimes you may not see this as part of the options, and so you further on factorize the common factors, then you reach the final answer. So this one, what's the common factor here? That is -2, right? So you bring -2 out, x minus y. Then you come down here. 2 goes into 6, right? So 2 is a factor of 6. So you say 2 into bracket x plus y, right? Sorry, x plus 3y. So this one cancel out this. And you can see your dy dx is equal to, the negative is still here. So negative x minus y over x plus 3y. Okay, so this is your final answer. Yeah. And someone can also expand this to get negative x plus y. So you see negative x plus y is the same as y minus x. So anyway, still it depends on the options provided. So if you believe yourself and you know you are right and you are not seeing the final answer as part of the options, you can check the answer, whether you can do something about the answer to get what the correct answer. Do you get it? Yes, because in this case they can give you y minus x over x plus 3y as the final answer. You can also see negative into bracket x minus y over x plus 3y as also part of the answer. Do you get it? Yeah, so it depends on the options available. Okay, so that is our final answer for the implicit function. So let's move on to the logarithm differentiation. So differentiation of a logarithm. Okay, that is the next one. Okay, so logarithm, logarithmic differentiation. Yes. So you see, the first one that we did under logarithmic differentiation, it was only about a function, logarithm of a function. So suppose you have y equals ln 2, let me say ln x squared, right? And so if you are differentiating it, you get dy dx equals, you differentiate this to get 2x, then you divide it by the same function, right? Do you remember? Yes. And so for this one that we are going to do, this one, you have a function, and that function also has an exponent as a function. Do you get it? And so at this point, what you have to do is you have to introduce logarithm on both sides of the equal sign. And so your left hand side, you have to introduce logarithm. Your right hand side, you have to introduce logarithm. But in this case, the question provided you logarithm already. Do you get it? But what we are going to do, you may have no logarithm, but you see a function which is having an exponent as a function. And so, for example, y equals, you have a function x, but this function x has an exponent 2x. Do you see that? And so you see, you cannot differentiate this. You cannot differentiate x to x just like that, as in using the power rule. Do you get it? If it were to be only 2, you would have used the power rule, but the exponent is 2x, so you can't use the power rule. And so in this case, you have to use what? Logarithm. That is what you are talking about. You introduce ln on both sides. So ln y equals ln x exponent 2x. That is the difference between this and the first one. Do you get it? Okay. So what you have to do here is, after introducing the ln, this exponent, which is a function, will come behind the ln. And so you have ln y, we are rewriting it again. 2x ln x. You have it like this. Okay. And so in this case, when you are differentiating it, this one, when you differentiate y, you log y, you get 1 over what? Y. But because it is y, you have to add your dy dx as usual. When you come here, this is one function, this is another function. Do you get it? So you have to treat it like the product rule. So here you hold this one constant, that is 2x, then you differentiate this. When you differentiate x, you get what? So it will multiply. You get 1 over x log x. This one, when you differentiate, this is what you are going to get. And so plus, just like the product 2, this one was held constant here. So this time around, we are going to hold this one constant here. So len x. Then we differentiate this. So if you differentiate 2x, what do you get? You get 2. Okay. So watch very carefully. So we have, now we are going to make dy dx the subject. We don't want 1 over y dy dx. We don't want this, but we want dy dx. Do you get it? And so what we have to do is, we are going to multiply through by y. Do you get it? In order to eliminate this. So you multiply here by y, the y will cancel this one. Then you multiply this term by y, this term by y. Do you see that? And so let me break it down first before I do the multiplication. Equal to, so this x here can cancel out this x. So 2 times 1 is what? 2. So you have 2 here, plus you have len x multiplying 2. So we say 2 len x. This is how we say it. Okay. So now we want to eliminate this fraction. In order to get our dy dx, what do? We multiply here by y. So you see, we have multiplied this whole thing by y equal to, we multiply this whole thing by y. 2 plus 2 len x. Okay, do you see that? So this y will cancel this. Now we don't have any y, 1 over y, but you have what? Dy dx equal to y into bracket 2 plus 2 len x. Okay, this is not your final answer because you have y here, and from the question, you know y is equal to what? X exponent 2x. Do you get it? You are differentiating y with respect to x, so you don't need to get y here. It's only when you are dealing with what? Implicit function, because that is a function within another function. So it's normal for you to get y on both sides. After getting dy dx, it's possible you get y on the other hand side of the equal sign. But when dealing with any other rule, you are supposed to get dy dx here, and in terms of what? X on your right hand side. So if you are having y here, it means you are still not done. So now you need to introduce what? The value of y, and the value of y is what? This. Y is equal to this. So we are now going to put this in place of the y, and we are done. Okay, so we have dy dx equal to x exponent 2x. So you have x exponent 2x, then you bring your equal sign, 2 plus 2 len x. You are good to go. So there is the final answer. There's your final answer. When you get here, you can tell yourself you are done. Okay, yes. So that is it for logarithmic differentiation. Okay. Think we have done it. Try this one and give me the answer at the comment section. Y equals 3 exponents x squared. Okay, so try this one and give me the answer at the comment section. Okay, so let's move on to the next one. That is how to test for points. How to test for points. How to test for points. In our next video, we will be looking at application of differentiation. And for application of differentiation, you need to know how to test for points. Do you get it? And so what we are going to do here is very, you must take it very serious. And you have to understand how to test for points. Do you get it? Yes. After differentiating, know how to test for points. That is what we are going to do at the moment. Okay. So our last topic under this is test for points. Okay. Yes. And so for test for points, we are going to look at either the point is what? Maximum points. Okay, either the point is maximum point or minimum point. Minimum points. Okay, we say whenever a point is maximum, it means the second differential of that particular point is always less than what? 0. Do you get it? It means if you find the second differential of any function and that number that you get is less than 0 or any number in the midst of what is negative, it means that point is what? Maximum point. Then if you get any number greater than 0, it means that point is what? Minimum point. And if you get anything equal to 0, it means it is point of what? Inflection. Point of inflection. That is when your second differential is equal to 0. Okay, yes, so that is basically what we are talking about. So for example, if you have y equals 2x squared plus 3x and you have been asked to determine whether this nature or this function is what? Maximum or minimum. Okay, so let's see. First differential dy dx is equal to, you know how to okay, let me teach you this one before. So after knowing maximum point, minimum point, and point of inflection, this is, we use this under the what? Second differential. So second differential, I'll give you the steps and we run through some example. So this is under second differential. Okay, before we move on to the question, so let me hold on the question for now. Then we use the first differential to estimate the points, then the second differential to determine the nature. Do you get it? So the first differential is for the points, estimating the points. That is for estimating the points. Do you get it? So it is the first differential that will tell you whether the points you are going to get 2, half, 0, 3, or whatever. So we derive these things, the points, from the first differential. Do you get it? Then we come to the second differential to determine these three. So anytime a question will ask you to determine the nature of a point, it means, have it in mind, you must what? Go to what? Second differential. But if you have been if you are asked to calculate for any point or estimate any point, yes, that is under first differential. Okay, yeah, we have something we call stationary point. So let me give you the steps. We take a question and we run through. Okay, so whenever you want to test for a point, we have some few steps that you must go through. So one, you have to first differentiate. You have to first find your first what? Differential. Okay, so you differentiate the points, sorry, the function. So you differentiate the function. You differentiate the function. That is normally what we call dy dx. Do you get it? Yeah. And so there is the first step. Then after differentiating the function, you have your dy dx, right? We have something we call stationary point. Now stationary point is when your dy dx is equal to what? 0 or turning point. So stationary point is the same as turning point. So that is when your dy dx is equal to 0. So before you estimate any point, you must first equate what? Dy dx equals what? 0. Do you get it? That will help you to find the values for x before you get y, then you build the point. I hope you get that. So you equate, so just equate dy dx to 0. Okay, let me say 0. Yes, to get your value of x, value for x. to get the values x. Okay, yes. So you equate your dy dx to 0, and when you equate it to 0, you solve for x. Now the values of x that you get, yes, you substitute those values into the function, because they will give you a question y equals 2x cubed plus 2x. So after getting the values for x, what you do is you pick one, you insert it in the function to get what? Y. Assuming x is equal to 1, so you put 1 here, you put 1 here, you have 2 plus 2, so your y is equal to 4. So it means if your x is equal to 1, y is equal to 4, you have gotten the first point. That is what we mean. Okay, so after getting the values of x, you substitute the values of x into the function. To find y. Okay, yeah, to find y. That is the third step. Then after getting the values of y, or let's say building your point, so 4, now you estimate, or now you derive your stationary point or turning point. Stationary points or turning points. Okay, yes. So you derive your stationary point or turning point. Then after getting the stationary point or turning point, what you have to do next is you find the second differential, because mind you, I told you earlier that the first differential is used to calculate for what? Stationary point or turning point. So after getting the first differential here, and after getting your stationary point or the turning point here, you must differentiate the function again. So the function which is dy dx, you must differentiate it again. So assuming this is our function and we had dy dx equals, this is what? 6x squared plus 2. Do you get it? So after getting our turning point and everything, we have to differentiate this thing again to get d square y over dx squared equal to what? 12x plus 2. Do you get it? So this one becomes our second differential. So find the second differential. Find the second differential. So you find the second differential. Yes, you find the second differential. After getting the second differential, you see you have what? X here. So the point that you got from here, that is 1 and 4, you put in, or you put in the value of what? X here, right? You are not going to use y, so you put in the value of x here. So you have 12 times 1 plus 2. So this one is 12 times 1 is 12 plus 2 is 14. Okay, so your d square y over, this is just a sample, just some rough example, but just follow the steps. I want to just explain the steps to you. So you have the square y over the s square as what? 14. So it means it is greater than 0. So if it is greater than 0, it means the answer is what? Or the point is what? A minimum point. Okay, so now we are going to solve a question under test for points. Okay, so we see our f of x is equal to 1 over 3x cubed. 1 over 3x cubed minus 2x squared plus 3x. So here they said we should determine the nature of the points. Okay, so determine the nature of the points. Okay, so now it means we have to build our points, and after we determine the nature of the point, whether the point is minimum or maximum, or it's on the point of what? Inflection. Okay, so from the steps, first, what do we have to do? We have to differentiate it. What? We have to differentiate the function. So this is what? F of x. And when you differentiate f of x, you get what? f prime of x. F of x here is the same as y, so you can change it to y and call it dy dx. So we say dy dx, this is the same as y. So dy dx or f prime of x is equal to 1 over 3 if you multiply it by 3, because this one is coming down to multiply the fraction. This one will cancel out this. So you have what? X. Then you reduce the exponent by 1, so 2. Minus this one will multiply this to give you 4x. Okay. Plus this one will give you what? 3. Right. So this is the first differential. So after determining the first differential, you must equate it to what? 0. Because we want to find what? The stationary point. And we say at the stationary point, or the turning point, dy dx or f prime of x is equal to what? 0. So here we are going to equate this to 0. So we say x squared minus 4x plus 3 is equal to what? 0. Okay, so this one, when you work it out on your calculator, there's quadratic equation. So you are going to get your x values as 1 or 3, right? So after getting 1 or 3, here you determine the values of what? Y, since you have what? X. Because we know nature of every point is what? X, Y, like this. But here lies the case, you have what? X. So where are the Y? So it means you have to insert what? The values of x into this function to get what? Y. Okay, let's do that very quick. So we say y equals, we are putting in 1, right? So we are substituting 1 into the function here. So we have 1 over 3, 1 cube minus 2, 1 squared plus 3, 1. Okay, so when you solve it, that is 4 on 3. Okay, yes, that is 4 on 3, right? Okay, then we do same for the second x, that is 3. We are substituting x, which is 3, into the function. So we have 1 on 3, 3 cube minus 2, 3 squared plus 3x. So this one, you have y equals what? 0. Okay, if you solve it, you get y equals 0. So now you can say for your point, whenever x is equal to 1, y is equal to 4 on 3. So your first point is what? 1, 4 on 3. So this is the first point. Then the second point, you have 3 and 0. Okay, so these are the stationary points. These are the stationary points. And now they said we should determine the nature of these points. Now if you want to determine the nature of these points, it means you have to find for what? Second differential. Okay, so the second differential, it means we have to differentiate the first differential in order to determine the point. Okay, so these are our stationary points. So we say stationary points or turning points. They are 1, 4, and 3, then 3, 0. So you are done with the first part. Okay, so for the second part, you just need to find for the differential of this, then you substitute x. So our dy dx is equal to what? X squared minus 4x plus 3. Okay, so now let's differentiate this to the second differential, that is the square y over the x squared, or you can say f prime of x is equal to, this one will give you what? 2x minus this one will give you negative what? 4, and this one is 0. Okay, so there is the function for the second differential. And now you have to what? Substitute what? The value of x in it. And if you get less than 0, it is what? Maximum. And if you get more than 0, it is minimum. So now our d square y over dx squared is equal to 2, our x is 1, right? Minus 4. So you have 2 minus 4 which is -2. So -2 is what? Less than 0. So here you can say for this point it is what? Maximum. Okay, so point what? 1, 4 on 3 is maximum. Okay, then we do same for the second point, that is the square y over the x squared is equal to 2. Now we insert 3 into the function. Okay, so -4. So now you have 6 minus 4 giving you what? 2. Sorry, yeah, it is 2 and this -2. And so with this one, you see the answer is more than 0. So if it is more than 0, we say it is minimum. So you say this point 0.30 is minimum. Okay, it's minimum. And so that is what we mean by what? Testing for points. Okay, so if you want to test for points, the most complex or the difficult part of the calculation is where you differentiate and you establish or derive the stationary point. So after getting the stationary point, you don't have anything tedious to do. That is, you just substitute the values of x into the second derivative. Then you decide whether the point is maximum or minimum. So that is for testing for points, and we are done with differentiation. We are going to meet for application of differentiation in our next video, and in our next video we are going to apply this same procedure. Whenever you hear maximum or minimum, it means you have to reach out towards the second differential. You must come here, and before you come here you have to pass through all these procedures. Do you get it? So have it in mind. If you hear maximum, minimum, you have to follow these procedures before you can solve for any question that you'll be asked to do. Okay, so once again, my name is Afari Ernest and this is grade 8 tutor. Kindly subscribe to our YouTube channel and you like our video. Thank you very much. We'll meet again.